In the unremitting operating environment of heavy industry, agro-industry and mining, the integrity, reliability and performance of big gearboxes are paramount. Unanticipated downtime, malfunctions and failures are increasingly regarded as absolutely unacceptable events. A heavy-duty gearbox should deliver to its stated factory specifications for the duration of its planned operating lifespan. Reliability engineering, a critical movement in contemporary industry thinking, requires that a plant be in full production without unnecessary maintenance or unplanned stoppages. It was this standpoint that prompted BMG to meet the exacting expectations of its customer base and develop a cutting-edge load test rig for large gearboxes at BMG Park in Johannesburg. The energy-efficient 200 kilowatt load test rig has the highest load capacity of any test rig in Southern Africa. Developed by BMG's technical resources team at BMG Park, the rig employs the latest technology to transmit and apply loads up to 30,000 Newton meters with the lowest possible energy consumption. It has been equipped with SPM condition monitoring equipment to accurately measure the condition of the gear mesh, bearings and lubrication under loaded conditions. Satisfactory results from these measurements ensure total reliability. The system doubles as a true-to-life demonstration platform to prove the power of condition-based maintenance for plant and machinery. Applications Engineer Manager Gareth Evans, with the spectacles, of BMG Park's Technical Resources team in Johannesburg, was part of the design team involved in the development of the load test rig. Gareth takes up the story.
Good day. The load test rig consists of four main components: the 200 kilowatt drive motor, the 200 kilowatt slave motor, the test gearbox which we check in the function of, and the slave gearbox. In simple terms, the way in which the system operates is as follows. The drive motor drives the test gearbox via a 1-to-1 ratio drive belt, tooth drive belt, which in turn, the test gearbox's low-speed shaft drives the slave gearbox's low-speed shaft via this elastomeric coupling. It actually drives backwards through the slave gearbox, thus increasing the input speed from the low-speed shaft to the high-speed shaft. The load on the system is actually created by the braking effect of the slave motor behind me, which is now actually operating as a generator. This load is applied to the slave gearbox's high-speed shaft also via a synchronous belt drive. But in this case, the ratio is not always 1-to-1 due to the different ratios of gearboxes that we have to test. The current which is generated by the braking of the slave or load motor is now rectified and injected back into the DC bus of the driving Saftronics inverter via the Danfoss inverter behind me. These inverters both controlled by the EcoDyne panel, which is connected to the controlling laptop which controls the full system. This type of system is extremely effective and only requires us to make up the system losses from the incoming supply. This allows us to conduct high power testing without high power demands from the incoming supply. Our testing, however, is limited to a maximum input power of 200 kilowatts and around 30,000 Newton meters at the low speed shafts behind me. Even at this power, we use the equivalent of about 37 kilowatts from the incoming supply, which is almost nothing.
Richards Bay branch manager Arthur Gray, who has been working closely with Richards Bay coal terminals for many years. RBCT was the BMG customer who initially requested gearbox load testing. Arthur relates his side of this story.
Folks, I'd like to share my experience with you. Some 9 years ago, we visited Richards Bay coal terminal, who happens to be one of the largest coal terminals in the world, with the guys from Paramax in the UK. And the purpose of the visit was to try and promote Paramax drives to Richards Bay coal terminal. However, we were told in no uncertain terms that unless we offered load testing, that we certainly wouldn't be even considered as a supplier to Richards Bay Coal Terminal. Proud to say that after years of research and development on the BMG test rig, together with the RBCT engineers, the design was approved by RBCT, thereafter by BMG's ExCo. They approved the capex for the rig to be built, subject to us being successful in obtaining orders from the Richards Bay Coal Terminal. Had it not been for BMG's vision, we would not have been successful at all in being approved as a gearbox supplier to the Richards Bay Coal Terminal. We have since used this as a marketing tool to help us gain further orders, namely at the Port of Richards Bay, and that without the rig, once again, we would not have been successful in getting that order, or those orders, should I say. I quote the Richards Bay Coal Terminal engineers, having stated on record that this rig is certainly the best in Southern Africa, if not the world. Folks, we have an amazing advantage over our competitors. We need to use this and promote this not only for the new products that we supply in the gearboxes, as well as the reconditioned drives that we repair in the various centres around the country.
The load test rig incorporates new technology, Gates poly-chain belt drives and a quick flex coupling for fast reconfiguration. The design accommodates the majority of Paramax gearbox sizes commonly used in South Africa. This facility confirms BMG's commitment not only to the requirements of its customers, but also to the Paramax range of helical and bevel helical speed reducers, which meet the demands of heavy-duty drive applications.